recall in our last video we talked about the Poisson random variable, which gave you the chance, let's say, of X arrivals at a Starbucks in a given period of time. Well, you might want to know what's the chance the time between arrivals is less than or equal to X minutes or X hours. There you would use the exponential random variable. This is a continuous random variable. It's based on a parameter lambda, which is the mean number of arrivals per unit time. And the exponential density looks something like this for the following example. Let's suppose the average time between arrivals and hours is 0.033 or 1/30th of an hour. So then the number of arrivals per hour is 1 over that, which is 30 arrivals per hour. Now this is the parameter you use with the EXPON.DIST function. So it'll ask for parameter lambda, which is the mean number of arrivals per unit time. And then it'll give you the chance that the time between arrivals is less than or equal to a particular number X, but you got to keep your units straight. Okay? And so let's take the following example again. It's on the average 0.0333 hours between arrivals. So the number of arrivals per hour on average will be 30. What's the chance it'll be less than or equal to 5 minutes between arrivals, or more than 5 minutes between arrivals, which is 1 minus that? Less than or equal to 10 minutes between arrivals, less than or equal to 15 minutes between arrivals, etc. Now, if you plot this density, which I've done here, you'll see it starts really high. Okay, remember, probability density function gives you an idea of how likely a value is, but it has a very long tail. Actually, it has the no memory property. It's the only random variable with this property. So if I told you it'd been 10 minutes between arrivals, or 20 minutes between arrivals, or 30 minutes between arrivals at least, then the chance of an arrival in the next minute stays exactly the same. It remains unchanged. That's really unique to the exponential random variable. And another property of the exponential random variable, the number of arrivals in a given time is Poisson. That's true if and only if the time between arrivals is exponential. So again, let's solve this problem here. We've got, again, on the average 0.0333 hours between arrivals, so 30 arrivals per hour. Okay, so what's the chance to be less than or equal to 5 minutes between arrivals, less than or equal to 10 minutes, or 1 minus that is greater than or equal to? So you got to convert the minutes to hours, because this is in hours. Okay, so 5 minutes is 1/12 of an hour, 10 minutes 1/6 of an hour, 15 minutes is 1/4 of an hour. So the chance to be less than or equal to 5 minutes between arrivals, there we go. So let's fill this in here. All right, so let's see what we got. So the X is going to be this many hours. The lambda we said was 30. And if you want the cumulative, you use true. If you turn it to false, you can get the height of this exponential density, but we don't really care about that. So you get 91.7%. Okay, there's a 92% chance there'll be an arrival within 5 minutes. And so 1 minus that will be the chance it's greater than or equal to 5 minutes between arrivals, 8%. Now there, I guess I didn't, got a $sign, the 2 there. Okay, so the chance that it would be less than or equal to 15 minutes between arrivals is like 9.999. So the chance to be 15 minutes or more between arrivals is like going to be 5 in 10,000. Now the relationship between the Poisson and the exponential that we discussed, let's check that here. So basically the chance of at least 5 minutes between arrivals is 8%, and the chance of 0 arrivals in 5 minutes should also be 8%. And we can get that from the Poisson. Oops, there we go. So we want the chance of 0 events, okay, in 5 minutes. So it's 30 mean is the mean per hour. So the mean in 5 minutes would be 30 times what fraction of an hour is 5 minutes? 5 over 60. So basically you'd expect basically in 5 minutes you'd expect 2.5, which is 1/12 of 30. You put false for the chance of 0. You could put true. You get exactly the same answer. The chance of 0 arrivals in 5 minutes is 8%, which is the same as the chance it'll be at least 5 minutes between arrivals. So again, the exponential random variable used a lot in the theory of waiting lines and queuing theory. In our supply chain module, we have some videos on waiting lines and queuing theory.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of three books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.